For this experiment, you will need a mixture of organic base, organic acid, and organic neutral substance. Here we're using 3-nitroaniline as a base, benzoic acid as the acid, and naphthalene as a neutral material that is neither acid nor base. You will need concentrated sodium hydroxide, concentrated hydrochloric acid, dichloromethane. The label on the bottle may say methylene chloride. Some small beakers, some graduated cylinders, a separating funnel with a stopper, a ring clamp, and stand. You will also need a Buchner funnel with filter papers, a Buchner flask, and a clamp and stand. It's also handy to have pH strips. Eye protection is required for this lab, and gloves are recommended. At the end of the lab, that 3-component mixture will be separated. Weigh out about a gram of the unknown mixture. Assemble the separatory funnel in a ring clamp attached to a stand. Always put a beaker underneath the separatory funnel. Here, as a default setting, the stopcock is closed and the stopper is in. Take about 15 milliliters of dichloromethane, also known as methylene chloride, and dissolve the 1 gram of mixture that you've put into a beaker. Give that a stir or a shake, let the whole thing dissolve, and then we will transfer it into the separatory funnel. Transfer the dissolved mixture into the separatory funnel. Then add about 5 milliliters of 6 molar hydrochloric acid. The hydrochloric acid is dissolved in water. Water and dichloromethane do not mix, therefore you will get 2 layers. However, the basic layer in the unknown is going to react with the acid to make a sodium salt. That sodium salt will be soluble in the aqueous layer. So we're going to stopper the flask, and holding on to the stopper and the glass carefully and tightly, we're going to invert this separatory funnel. Point the funnel end away from everybody to the back of the hood, and then just carefully vent through the stopcock. Close the stopcock again nice and tight, and then give this a swirl. Now vent again. Dichloromethane is very volatile, so you will build a vapor pressure inside this flask. With it vented twice, you can now go ahead and shake this separatory funnel. Do this procedure 2 or 3 times. Then put the separatory funnel back in the stand and remove the stopper. We always keep a beaker underneath the ring stand just in case of emergencies. This separatory funnel has a Teflon stopcock rather than the glass one, and so errors are less likely with this kind. At first attempt, we've made a foamy top layer where not everything has been able to dissolve in the aqueous layer. So we're going to go ahead and add another aliquot, another measured amount of acid, to see if we can get this to dissolve. Go ahead, there. We'll give that a shake and run through the whole process again. Took an additional 10 or 15 milliliters of hydrochloric acid to make the globular solids in the upper layer go away. So we now have the stopper off this separatory funnel. We're going to give this a couple of minutes to let the layers separate fully. Bottom layer is the organic layer. It contains the benzoic acid and the naphthalene. Upper layer is the salt of the amine. We're going to drain that bottom layer, the organic layer in dichloromethane that currently contains the acid and the neutral component. Going to open that stopcock very, very slowly and let that drain. We also have another beaker ready that is labeled that will take the upper layer, which is the salt of the base. Students in this experiment have opted to add acid to the mixture first. This is a slightly different order than is in the lab manual, but the sequence of events is unimportant. You can do the acid extraction first or the base extraction first. It makes no difference to the overall result. When this layer reaches this part of the stopcock, we will close it. Okay, we're going to move the organic layer to the side and then drain the aqueous layer into a new clean beaker that is labeled. You can open this stopcock all the way and just let everything drain out. Okay, now we're going to close that stopcock and then put the organic layer that contains the acid and the neutral back into the separatory funnel, ready for its next extraction. Stopper that. And the salt of the base is only being kept in aqueous solution because it is highly acidic. If we rebasify this, it will precipitate. Knowing full well that we've added about 15 milliliters of 6 molar hydrochloric acid to this solution, and it is very, very acidic, we've measured out about an equal amount of 6 molar sodium hydroxide. And when we make this solution basic, the base should precipitate. All acid-base neutralizations are, of course, exothermic. But we now have a precipitate. If we test the pH of this solution, that solution is still acidic. We need to make this solution basic before all the precipitate will come out. Okay, addition of another few milliliters of concentrated sodium hydroxide has yielded a basic solution, which means that our salt will have fully precipitated. I'm going to just leave that at the back of this fume hood for a little while we get on with the remainder of the extraction. Set up a Buchner funnel fitted with filter paper into a Buchner flask and then attach this vacuum hosing to a vacuum supply. We're going to take the salt of the base, which has precipitated, and pour it into the funnel, the intention being to get as much of the solid onto the filter paper as we possibly can. We're going to let the collected precipitate dry on the filter under vacuum for several minutes. After a few minutes, this is the solid nitroaniline, the base that we have recovered from the experiment. Once it's fully dry, it is ready to be measured by mass. With a protective beaker underneath the separatory funnel, we're going to take 10 milliliters of concentrated 6 molar sodium hydroxide and add that to our solution of benzoic acid and naphthalene. This is our acidic and neutral component. The base will react with the benzoic acid and make the sodium salt sodium benzoate. Sodium benzoate will be soluble in water, which again has made an upper layer. The dichloromethane is the lower level here. With the stopper in, take that out, give it a good shake. Drain the lower organic layer, which should contain just the naphthalene, very slowly into a pre-labeled beaker. The upper aqueous layer contains sodium benzoate, the salt of the acid. Once the bottom layer has drained through, switch out the beakers and drain the upper acid salt into its own beaker. This contains sodium benzoate, which is soluble in water, as all sodium salts are. If we add several milliliters of hydrochloric acid and we re-acidify this solution, we should be able to precipitate the benzoic acid. Okay, if we re-acidify the sodium benzoate, which you can see currently is a basic solution, the sodium benzoate will precipitate. Cooling these solutions down is always an aid to precipitation, especially sodium benzoate, as it's not particularly insoluble in water. Adding acid and cooling in an ice bath has precipitated the benzoic acid, and we can see here that our little test strip has tested positive for acid. This solution is now acidic. Fit a clean Buchner funnel with a filter paper, and then we're going to go ahead and perform a second vacuum filtration to isolate the benzoic acid.